for it to take place in a matter of milliseconds is an amazing physics feat.
We generally get one chance at things we do.
The 300-foot test achieved higher pressures and longer pulse duration than ever previously achieved.
There's no other way to simulate the kind of environment they would have to survive in real-world use. Blast Tube is a facility designed to simulate blast environments on various test articles, buildings, or aerodynamic structures. It allows you to control all the various important parameters of a blast, so pressure, pulse duration, shockwave velocity, those kinds of things.
Pulse duration is basically how long you're hitting something, and then the pressure is how hard you're hitting it. Both of those play into the amount of energy that's put into your test unit.
What makes this blast tube unique is the fact that we can tailor to a sponsor's test needs. We really want to work with the sponsor to determine exactly what their needs are, and we start that early on, sometimes a year in advance. We start off planning efforts working with our modeling and simulation team.
Simulations help us answer questions like, how much charge can we put in there so that the tube won't break and the supports won't break, so that when we actually run the test, it's not a guessing game. The simulations basically tell us what are our limits. The simulations predicted that the supports in the tube would survive, and they did.
When we did the testing to bring this facility online, it was remarkable the pressures we could achieve with the lack of damage to the facility.
The results from the testing will help us validate our models and improve our accuracy and predictiveness.
We're collecting data they've never had before. Probably the only other way to test something like this would be an open air charge. But you lose a lot of pressure as it goes out into open space, and so you can focus that blast energy right on your test article here. And then the fact that it goes through a tube allows you to control all the various parameters. So you can have extreme repeatability in a test.
We are able to work with different lengths, different tube diameters, different thicknesses.
You can instrument heavily at a blast tube, which allows you to collect a lot more data than, say, if the test article were moving somehow. We can test to these pressures on test articles that are classified, that have high explosives in them, maybe hazardous materials. We're detonating hundreds of pounds of explosives in and around this tube. And we not only got pressures that we'd never seen before and pulse durations that exceeded our expectations, but to exceed those as much as we did and not hit our facility limits was pretty remarkable.